All right. Well, it's great to see everybody. Welcome to Math 219 Statistics. And, one thing, I'm John Zarski. I've been teaching at SAC for, if you look at the bio in Canvas, it says I've been teaching at SAC for about 26 years, and I started teaching a few years, about 5 years before that at Golden West College. And so been around here doing this for a long time. And I've taught stats just about every semester since. And stats is a lot of fun. I teach course pre-calculus. I've taught calculus. I've taught algebra. I've taught trig, all kinds of things. And but statistics is neat because it's a unique class. It's a different kind of an animal. This is one class. Even if you didn't like algebra, you might like statistics. It's a completely different class. This is actually one class you'll see lots of applications of statistics in the outside world. So many times we hear things in the news. We hear about the lottery. That's something we're going to talk about at the end of chapter 5. And like the probability of winning the lottery. And I'm sure you've heard of studies and that say like smoking causes lung cancer. We all kind of know that, but there's statistical studies where they gather data and then they crunch the numbers and conclude, yeah, looks like smoking's causing lung cancer. Or even when we have an election, you see, like a margin of error, plus or minus 3% or something like that. We're going to calculate that. So later, not today, but there's just so much in this course that you will see in the outside world. And a lot of you, if you have any statistics in your future, maybe you're majoring in psychology or sociology or even economics, they all use statistics. And so this is just an introduction, gives you a wide view of the statistical world. And then you go on and do whatever you need to do and learn whatever you need to learn relative to the whatever profession you choose. So this is like I say, this is a really good course. It's I would say it's somewhere between, it's not super easy cakewalk, but it's not challenging like pre-calculus or calculus. So main thing is you keep up with the assignments. You're here, should be okay. Okay, and get your questions answered. So let's take a few minutes. I lost track of who's in here. I'll do the roll, I guess, in a little bit. I assume probably more people will arrive. But what I want to do is take a few minutes and just quickly go over the syllabus, just some of the highlights there. So I'm going to share my screen right now. And then, okay, now I always have to, you might notice that there are two of me here. There's a picture. What I do is I always run my computer. I run the meeting from my tablet, and then I have my computer. If you see me looking to the left like I am now, I'm looking at the computer. That's how I keep track of the chat. And then also, I like to be able to see what you guys are seeing, make sure I'm broadcasting and showing the correct screens and everything else. So what you see here, of course, in Canvas. Now, one thing about the modules, when I record the lectures, what I'm going to do is then post the link under the modules. So we're in Unit 1, getting ready for exam 1, so the recordings will go right here. Now, the other thing I want to look at is the syllabus. There's the syllabus and the schedule. So the syllabus is what I want to look at right now. And And I'm just going to go ahead and download it just so it's easier to read. Okay, so lots of great information in here. You guys have already gotten onto my lab and you're already here, so you know about the lectures. Right down in here, I want to point out that I do have PowerPoint slides that have the notes and kind of the more important stuff. There's a lot of stuff in the book. Of course, book has quite a collection of material. The PowerPoint slides, though, that's a little bit more of the important stuff, the stuff that you should maybe focus on. And it'd be good to have those out when you're watching the media assignments. I'll talk about those in a few minutes. But just right in here, notice right in here in the syllabus, this is the path to the PowerPoints. You go into My Lab, Communication Tools, Document Sharing. And what that looks like is under My Lab. Of course, it looks a little different under my between yours and mine, but it's then we've got, wait a minute, hold on, I need to scroll down a little bit. Communication, whoops, not there. There we go. Communication tools. See, I have some other tools in here. And then document sharing. And then that has all the files. Now, what you're going to see is just chapters. I think I enabled all the chapters, or at least maybe chapters 1 through 4. No, I actually did. It looks like I enabled all of the chapters in the class. So then what you would do is go ahead, and they're PDFs. So for example, a chapter 1 PDF, you go ahead and click on that, and looks like that. So those are the notes that I'll be using. I have the PowerPoints that I'll be using in each chapter. So it's a really good idea to find these and print them up if you can. Have them out when you're doing the media assignments. And I'll explain the media assignments in a few minutes. But like I say, these PowerPoints can be pretty handy, right? So let's see, back to the syllabus. Syllabus keeps me on track.
Sorry.
Yeah.
Had a question. Where I'm on My Lab statistics.
Yeah.
And where did you find the PowerPoints? Where is it at again? I'm trying to follow.
You should, along the left side, there should be communication tools.
Communication tool. Okay, there you go. I see it. Okay.
And then click that and then document sharing.
So when I see communication document sharing, okay.
And then the whole list of documents. Now, what you're seeing on your screen on my side, I have more than what you need. See, I have the PowerPoints I use, but then I also have the PDFs that you need. So you'll see, you can even see on the screen, you can see instructor only an entire class. So there's some, I use this to store everything, and then whatever you guys need, I just enable it for the whole class.
So the first one that I see says chapter 15 PowerPoint slides. Is that the one that I should be?
No, we start with chapter 1. They're kind of
that makes sense. I know it would be one, but I'm trying to see. Oh, is it doing it backwards? It's doing it backwards. Okay.
Yeah, the thing is I think what happened is the order. I don't have a way to reorder them. I haven't figured that out. And I think what it did, of course, when I uploaded them, I uploaded chapter 1 first, and then chapter 2 second, and then it just kept stacking them up. And so they're kind of,
you know what? Yeah, I actually do not see, I don't know if anybody else isn't seeing chapter 1. I only see chapter 2. Chapter 2 F21 6 PP PDF. And then it goes chapter 3, chapter 4, chapter 5.
There should be a chapter 1. In fact, I see it's showing me that 10 people have downloaded.
I don't know if anybody wants to check on their end as well, but I'm only seeing chapter 2, 3, 4, all the way to 15.
Well, maybe you could stick around. Yeah, if you want to stick around afterwards, I do have an office hour after class, and then what I can do is maybe I can enable it to where you can share your screen, and then I can see what's going on. And that's kind of weird.
Oh, Ariana's saying she sees chapter 1. I don't know. I don't even see it. Yeah. Huh. Okay. Well, we'll figure that later.
Yeah. It's you see the file you'll be looking for is the one that's on the bottom of mine. It says chapter 1 F21, and that the 6
maybe I need to refresh it or something.
Maybe.
Oh, I found it when I refreshed it. I saw it. Okay.
Awesome.
Cool.
Okay.
Okay, nice. Okay, cool.
Great.
Thank you.
Anytime, anytime. We're here. I love the conversation. I love the participation. In fact, that's one thing that I do want to mention, in here, that love the participation in the beginning of class, not so much today, but I do take roll at the beginning, and then you get extra if you show live video, because I like, it helps for you to see me. I'll always be live. It doesn't, but it also helps me to see you and your expressions and things like that. So I actually give participation for showing live video. So you do need to have a camera. I won't do that. I'll give everybody full credit on the participation today, in case you just rolled out of bed and you're like, oh man, I don't want to be on live video. But the thing is that when we do quizzes, you do need to be on live video. So, and if that actually I just thought about that, and if we're having a quiz, I guess I need to do that. But if that's a problem, message me and we'll figure that out. But that's where participation, I want there to be some participation in here. One thing that I don't know, probably most of you know about this, but there's also an app that goes with Canvas, and it's called Pronto. And Pronto is a messaging app that you can put on your smartphone, but it also works through Canvas. When you get Pronto, you can see the icon right there that I'm going, circling it right there. So you can access it through Canvas, but you put Pronto on your phone. It's a messaging app. You can message me, you can message the whole class, I can message you. It's just another communication tool. And so that's kind of cool. We like Pronto. And so what I do sometimes during class to check for participation and make sure people are alive and awake is I'll give you a question, and then you respond on Pronto. And then whether it's right or wrong, doesn't matter. I just know that you're there. And so the fact that you're participating. So I do keep an eye on things. Like I say, I love to see faces out there rather than blank names. All right, let's look at homework right here. You guys have discovered the homework. Now, you'll notice that there are two types of assignments. When you go to MyLab, there are what's called the media assignments, and then there are the regular assignments. So let me go to course home. Your course home is where you want to live as far as MyLab is concerned, because what it does is it tells you everything you need to do. And it's not telling me, oh, you know what? I need to give it the month because I extended things. Okay, so you can see here listed there are two types of assignments, 1.1 media, 1.1 homework. Now, ideally, the medias are prep assignments. So they are typically due the day we cover something. Now, I had to double up with chapter 1, of course, because today is the first day. But then you would have noticed that what I also assigned was 2.1 media, 2.2 media, 2.3 media. When you do those, that gets you ready for the conversation we have today. We're going to talk about chapter 2. So this is kind of an online kind of hybrid. We meet, of course, but a lot of the learning you're going to do is going to be outside of class through the medias. Then we go over the material, I answer questions, then you're ready to do the homework. So let me go ahead and look at, say, for example, because I pretty much extended just about all of the work. Let me see, let's see, is everything due on the 24th? Oh geez, just about everything is due next time, because we have a holiday next time, and then we've got an exam after that. Wow. Okay, so there's a lot of work to do over the next couple of weeks. So basically what you do is, again, start here. Hopefully you've done chapter 1, but anyway, you start here and you just keep working your way down the assignments. Now, you might ask, do I have to do the medias? Yeah, you do. Okay, because you have to get like a 80 or 90% on the medias, and there's only a couple of questions on there, a few questions, in order to unlock the homework. All right, so you shouldn't just skip around. Just go ahead, start with 1.1 media, and if you've done that, go ahead and start and work your way down on the rest. So wait a minute. Okay, hold on a second. I'm looking at our schedule, and let's see. Oh yeah, okay. So on the 24th, okay, there's quite a list here. On the 24th, of course, I have already I extended everything that was due today. All right. So we're also going to be talking about chapter 2. So the chapter 2 homework will be due next time. But then also next time, notice, like say, for example, you see 3.3 media, 3.4 media, 3.5. Those sections we'll be talking about next time. So you do the medias ahead of time to get ready for class. All right. And does that make sense? I hope that makes sense. It kind of explains it right here. And then let's see what else. Oh, then we have the quizzes. We'll have a little quiz today, again on chapter 1. It's just a really quick multiple choice thing. Won't take you very long. We'll do that a little later. And they will be done through my lab. And like I say, we do need to show some live video and all. Exams, we do have some exams. Now, let me go back to Canvas, and the syllabus is a good document, but then also the schedule. That schedule, it shows what we do from week to week. So again, like it says up here, media assignment for a particular section is due on the day we cover that section. And then it says at the top, homework is due the next day. So for example, on the 24th, all of these, the medias for 3.3, 3.4, 3.5, 4.1, 4.2 are due. So then that's the prep. So you come in next time we meet in 2 weeks, and then we are able to cover those assignments and then hopefully review, answer questions. In that time, I'll also be asking you questions, answering on pronto, and hopefully by the time we're done with class on Friday, you'll be in a good place to do the homework and get ready for the exam the following week. So this class, I don't know, this class I see as a double-edged sword, or there's good news and bad news. It's like, woohoo, hey, it's on Friday only. Yeah, all right, only Friday. But then when we realize the price of that is we cover a lot every day, and you have to do a lot of work between each meeting, that can be a challenge. So so that's where I say it's kind of a double-edged sword. But as long as you stay on track, my lab will keep you on track. You should be okay. Now, okay, we have some exams. Again, exams need live video. We're going to be doing some computer assignments. Those are during the second half of the semester. That's after spring break. I'll give you more information on those later. Extra credit, you can get some extra credit if you point out a mathematical mistake here during class. Also, if you go to the Math Center is a resource center. It's L204 on campus, but you can also join the Math Center virtually. Okay, what you can do is you can go to, I'll show you how to do it right here. If you go to sac.edu/math, actually, I think it's /math center. I usually go /math, and then I just saw something recently. Let me try this, see if it works. I just thought of this. Look at that, there it is, sac.edu/math center. And so what you can do is, there is a new link every day. Oh, wow, this is showing Thursday. Oh, you know why? Because the Math Center is not open yet today. So you go to this website, this link changes every day. You click on the link and you can join it virtually through Zoom. Okay, and you can still get extra credit. Now, the extra credit is 1 point per hour and a maximum of 2 points per week. So if you go to the Math Center for 2 hours a week, you'll get as much as 32 extra points, and those points get added to a test. So that is like super cool. All right. So Math Center is a great place to go. Let's see, there was something. Oh, I see. Oh, I'm seeing some stuff in the chat. Okay, you can see chapter one. Oh, okay, that has to do with the PowerPoints. Brooke, 14 try. Yes, the 14-day trial for my lab is good. Of course, that gets you going, but eventually we'll need to pay for the access. Now, how you pay, you have two options. You can either buy the an access code through the SAC bookstore, or you can buy it the access online just right while you're logged into my lab. There's a little thing, upgrade my access, excuse me, and you can do it that way. Okay, so some people are on financial aid. If you get financial aid checks or a bookstore card or something like that, where you have to, you buy things through the bookstore, you can buy it that way. But once the 14-day free trial expires, then you're kind of dead in the water. You won't be able to do any homework or any quizzes or tests or anything like that. So we do need to get on top of that. So yeah, Brooke, I'm glad you brought that up. Let's see, quizzes, exams, labs. I talked about extra credit. The times to find me outside of class. I have a couple of different kinds of office hours. I have live office hours, and these office hours, they might seem like strange times, but they are before and after my Monday, Wednesday classes. I teach 2 pre-calculus classes back to back on Mondays and Wednesdays. And so that's where I have some times, again, some live times. And that's why I say H101-4, that's my office, or H105, that's the classroom that I'm in. And so those are live office hours. If you happen to be on campus and you want to come see me, those are on Mondays and Wednesdays. And then I do some virtual office hours. Now, the ones that I think you'll be the most interested in are the Friday. I do before class, half an hour before class, and then an hour after class. So stick around afterwards if you have any questions. But I also have some office hours. And this one says Tuesday. On Tuesday, this upcoming Tuesday, I have an appointment, so I switched it to Thursday. If you ever want the most updated times to come find me, there's a module here in Canvas, and it says instructor contact. Go to instructor contact right here. And you can see right there, I will keep this updated if there are any changes. So you can see right here, updated office hours for weeks 1 and 2, my virtual switch to Thursday. All right. So anyway, if you have any questions, but you can always send me an email. Even if it's during office hours, I'll get back to you pretty soon. And if it's not during office hours, within 24 hours, and usually faster than that. So let's see, what else is there? Okay, grading scale. We got all the stuff, participation's in there. So yeah, good to participate. Best advice I can give you is work hard and don't let yourself get behind. We're going to be going quite fast, and it will be difficult to get caught up. If you miss one day is one whole week. So that's where I say, since we meet only once a week, it is critical that you attend all class sessions and keep up with the media assignments and come to class prepared. Remember, the media assignments get you prepared for class. And so and again, they get locked out. If you don't do those and you don't come to class prepared, then you get locked out of doing the homework assignments, and we have to have a conversation. So the main thing for you, keep up with the medias, keep an eye on your home screen on what's due, and then you're okay. Let's see, read the book. As long as you keep up with the media assignments, you're good. Lectures will be recorded. So if you miss a day, it is your responsibility to watch the recording and keep up. This work class will require you to spend roughly 2 hours of studying outside for every hour in. We meet 4 hours, so that would mean 8 hours a week. And we started this week. We couldn't give up this week. That's why I asked you to do chapter 1 again, because of the holidays and just the schedule. And then you can see if you have a disability, need accommodation, you can call this number for an evaluation. And of course, you get a letter, and you email me the letter and all that. If you drop the class, your responsibility to drop the class, and you may be dropped. Okay, our board policy, if you miss more than 10% of a course, you can be dropped for any reason, regardless of the reason, even if it's a good reason for missing the course. Now, it doesn't mean I will, but if I see a couple of absences, doesn't look like you're coming back, I'll drop you. If you have something going on, let me know. We can work it out. Again, you can always watch the recordings, get it done. This is kind of like a live online course. Online courses, you do a lot of the work yourself, a lot of the learning yourself, but you got some live time where you can ask me questions and we can have discussions. So it's kind of the best of both worlds. And so no cheating, all the tests are, closed notes, no chat, what's that chat? I lost it. G something. What's that AI? GPT, I think. But anyway, so we all do our own work, and I think that's pretty much it for the syllabus. The one thing I did want to point out back here on the schedule is I was talking about this a little bit before class with some of you, but I really struggled with the schedule when I realized Friday only class and then 2 holidays. You see, we have a holiday in 1 week, so we don't meet again. And then the next time we meet is in 2 weeks, and we finish off with chapter 4, and then we have an exam the following week. So we got to keep going. But if you got chapter 1, what's nice with the holiday, at least you got 2 weeks to get a lot of this work done. You have to get it done and stay caught up. And then notice a little bit further, in the 31st, we've got Cesar Chavez holiday, and then that's right in front of spring break. So the other thing that I struggled with is I wanted to get this second exam in before those 2 holidays, because after that exam, I don't see you for another 3 weeks. And if we had any material, we forget everything. We're human, okay? So I really wanted to squeeze that exam number 2 right in there. And I figured the only way we can do that is by taking advantage of this week and getting chapter 1 done. So then we come back from spring break and we start with the second half of the class, chapters 8, 9, 10, and so on. So that keeps us right on schedule with where we would be if we were, just regular 2-day-a-week class without all these holidays. All right. So any questions about the syllabus or anything? Are we all good? Let's see. I'm not seeing anything in
Question.
Yeah.
Hi. I had a question regarding the quiz. It's going to be on My Math Lab, just like how we did the homework, the assignments.
Yes.
Is there a way you can show me where it's at exactly, so I won't be?
Oh, it's not appeared yet because it's not activated.
So it'll pop up. Okay.
The best place to find it would be under assignments, but it'll also be under your course home. So like right here, I've clicked on the assignments. This is another way to access your assignments. If you just click on assignments, you'll see all the assignments. Now that green flag right there means, like, look at that. You see, you got to score at least 80% on the media before doing the homework. So that's where the medias are important. I do that just to try to poke and prod and keep you guys right on track. But what you will see, I have the quiz. I'll activate the quiz when we're ready to take it. But I actually, usually what happens, I think I have it to activate at like 9 o'clock, but whether we're ready to take it at 9 or not doesn't matter. I'll change the time, but yeah, it'll be under the assignments. And then it's always password protected. So you really can't take it unless you're in class and everything. And I'll be taking roll during class. So again, in class, you get the password, again, showing live video and all of that stuff while we do the quiz. So yeah, so that's where it'll be. Just
And now for the chapter 1 homework. You mentioned earlier that you opened it up so you can attempt to do it again. Is that for all of it, or is that just going to be for this week with chapter 1 and 2? Or
actually everything now, everything that was due today is now opened up. In fact, if you look along the left column right there, it now says all due on the 24th. So everything's been extended for 2 weeks. So you can go back, you can get 100%. The goal should be 100% on everything, you know, it helps your grade. But then if there was anything you didn't get to, you can do it. If there's, and then again, we got the holidays, so there is a lot of work to do. So don't put it off till the last minute. And again, if you have any questions, you got 2 options. There's me, office hours, virtual office hours or on-campus office hours, but also me in the math center, which I don't think I said when I'm in the math center. It is when I said, let me go back to the module of instructor contact, also listed on the syllabus. If you see right here, okay, a little bit bio, a little bit about me. Okay, live office hours, virtual office hours, other times by appointment, but also the math center. And I'm in the math center for 2 hours Monday afternoon. So if you all are on campus or you want to come to campus and see me personally, I can help you face to face. And I even put a link to the math center right in here. You can click on that. And I'll take you to that same website that I showed you earlier. Is that okay?
Yes, thank you.
Awesome. All right. I love questions, love the conversation, and hopefully you'll feel okay with asking me questions, because I love the discussion, and it really kind of energizes. Well, I always feel I've done a lot of performing in front of people. You can see in my bio here, we used to have a little rock and roll band here at SAC called the SAC Pack. I was in that for a while. I was in the USC marching band. I've performed in front of a lot of people and been in movies and done all kinds of fun stuff. And so, you know, when the crowd is cheering, that just energizes you to do well. And so I feel the same thing when I'm in class. And so so that's where I really appreciate the conversation. And you can see here, I got a son and a daughter, a couple of German Shepherds. And like I say, I'm surprised that they haven't come in yet. They usually come in about every hour or so. You might even hear them bark. If any of you know anything about German Shepherds, is that they bark about everything and they bark about nothing. So usually you will hear them in the background for some reason. But anyway, you'll meet them eventually. So any questions about the class, my lab? Like I say, you all have come up with some good questions. Really, like I say, I appreciate all the questions and everything. Any other questions that you can think of? If not, what I'd like to do is just say a few words about chapter 1, you know, just kind of an overview, and maybe stimulate any questions that you might have. Now, what I do when I do an overview of when I say an overview of a section, I call it a lecture, call it an overview. What I do here online with Zoom is I do a little split screen. So you'll see the PowerPoint, but then also the Word document on the right side. That is my whiteboard. So I can write on there and we can do examples. And I know my writing's terrible, but that's just the way it is. It says hello. So anyway, I just want to step through the sections, maybe spend about 5 minutes per section or a little more, we'll see, and then answer any questions that you want. And again, it's just kind of a quick overview just to kind of get your mind in math mode with the quiz coming up. So even if maybe you did the homework earlier in the week and kind of forgot a little bit, hopefully with a little overview and maybe any questions that you have, then that'll, kind of refresh your memory and everything like that. Okay, so let's, now chapter 1, you got section 1.1 right here. It says Introduction to Statistics. Chapter 1 is all definitions. It's all so we can talk like a statistician. And again, it's the least painful chapter. And I usually tell students, hey, it's like, stepping into this class is like stepping into a nice warm pool. The first chapter is all right, and everybody's like, hey, this is easy, this is all right. And then it does get a little more challenging. Not too bad, but again, a little bit more challenging. It's not just all definitions, but the first chapter is usually pretty tame, maybe would be a good description of it. So statistics, hold on, okay. So some of the definitions, I'm going to highlight some of the definitions. Of course, statistics, this is what we do. Okay, this is a summary of the whole course. So I definitely wanted to say something about this. And it says it's the science of collecting, organizing, summarizing, analyzing, and drawing conclusions or answering questions. And all of that pretty much describes in a nutshell what we do in this class. So the idea of collecting and organizing and summarizing data, that's pretty much the first couple of chapters. We learn, again, definitions in chapter 1, and what we're going to talk a little bit about later today is chapter 2, and kind of organizing data, and again, just learning some of the definitions of statistics. And of course, you see, well, I've already used the word data. You know what that is. That's the information that you collect. We have 2 different groups that we look at. The population is the entire group. So if I'm thinking maybe the average age of everyone here at Santa Ana College, like all SAC students. So for example, the population might be SAC students. And then a sample is a subset of that. That's the group that you're studying. Like maybe you guys might be a sample. All right. So maybe an example of a sample might be this class. Okay. So population and sample, a couple of different, definitions we want to keep an eye on. Then I'm going to go ahead and skip down here to parameter and statistic. Parameter.
Mr.
Yeah.
So this is all found on the PowerPoint.
Yes. Yeah, this is the PowerPoint.
Okay, this is okay.
Yeah. So when you print it up, like you say, let me bring that back. Let's see, where was that? Let's see, it would have been a PDF. I think it came up right there. No, where did that go? Had it around here someplace. I looked at it. Oh, wait a minute. Right here. There it is. So this is, yeah, what I showed you, that PDF. It's just the slides. So if you happen to have them, or if you're around a printer, if you want to print them up, and you can kind of highlight some of the things. I like the PowerPoints because it keeps you from having to write everything down like super fast. There's no reason for that. So typically what I'll do is I have the PowerPoints, And then a lot of the examples I do are out of the book. So when you're taking notes, I'm glad you asked about that, because that makes me think of other things. So it's not just the PowerPoints with the definitions and a lot of that information. Then the other stuff, like examples that I might work or that we'll do in class. Sometimes I'll pull things out of the book or pull things off of my lab. And then, so those are a little bit separate. So that's where I have both. I have the PowerPoints and then I have my little whiteboard on the side. Is that okay? Cool. I like to check to make sure I answered the question. Okay, so a parameter is a number from a population. Okay. So a parameter is a number that represents the population. So if I have the average age of all SAC students, we would call that a parameter. That's a number from the whole group. And then a statistic is a number from the sample. So if I had the average age of you guys, that would be a statistic. So parameter and statistic, those are some things, those are some definitions we'll be using in the future. Again, the ones I'm really highlighting are definitions we will be using, and you'll see in the future that you want to be certainly keep an eye on. Now in a little bit later right here, we have qualitative and quantitative. I know those are really big words, but when you look at qualitative, it's like qualities. And qualities are maybe things like your maybe eye color, hair color, your major, or where you live. So categorical things, labels. All right, you can see I put, have some of those things. So qualitative data is more qualities. Quantitative data, okay, you look at the first few letters of that and it looks like quantities. So quantities, and that's how many, and it's numerical data. So if I asked you, how far do you live from Santa Ana College, or how old are you, or how many units are you taking, okay, then that is numerical data. So qualitative versus quantitative. And so qualities versus quantities. All right, so those are some things we'll be using in the future. There's a level of measurement here that, let's see, a little bit further down. Oh, I ended up skipping too far. Okay. Another thing we're going to use here is discrete and continuous. Now, honestly, I'm going to read the definitions, and when you watch the video on this, I could see where maybe you might be a little bit confused on these. So I want to say a few words about them, and I want to tell you how I sort them out in my head. Okay, so let's read what it says first. Now, you see with this graphic down here, you can see that, okay, there's qualitative variables. Remember, qualitative, those are labels. Categorical data, again, like eye color and your major or whatever. Quantitative, again, are numbers. Now, numbers can be divided into two subgroups of discrete and continuous. Now, discrete, it says here, quantitative variable that has either a finite number of possible values or countable number of possible values. The term countable. Okay. Like I say, finite means a specific number of possible values. All right, finite is specific number. Or the way I think about it, and this is not in any of the videos, this is Mr. Zarsky talking, is that lots of decimals don't make sense. So examples of discrete, let's put it on the whiteboard. So some examples, maybe how many units are you taking? How many units? Would it make sense to say, yeah, I'm taking 5.2356 units? No. Okay, you can take 5.5. Okay, but it doesn't go any further than that. All right, if we're talking about maybe the cost of a textbook. So then the cost of a textbook is also discrete, because now I know textbooks are expensive. We could say that, yeah, the cost of a textbook might be $125.23. And again, that would be okay. But if we had lots of decimals, would not make sense. Kind of see what I'm saying? It's like the decimals have to stop. So when the decimals have to stop, that means you have a finite number of possible values. Continuous means lots of decimals can still make sense. I'm not seeing any space, so I'm going to write on my whiteboard. So for continuous, lots of decimals still make sense. So say, for example, if an example of a continuous variable or continuous data would be maybe the weight of a dog. We just took the dogs to the vet yesterday and they're a little overweight. All right. So if one of them was 105 pounds, 105, but if we had a super accurate scale, it could be 105.3867, whatever. If we have a super accurate scale, it can still make sense. So that would be something continuous. So pretty much continuous is really any kind of measurement. Anytime you have a measurement, you can have lots of decimals, and the only thing that limits your decimals is, well, how accurate your scale is. All right. So that's one thing. And let's see, I'm going to jump up to section 1.2. We have these levels of measurement. And again, I want to highlight kind of the things that we're going to see in the future. The levels of measurement, we see them here, but not much in the future. So they're nice, good to know. But again, the main point of what I'm doing right now is kind of letting you know what you're going to see, what we're going to see later in the course. And so I'm going up to this slide 16, and they talk about response variable and explanatory variable. So let's look at the example right here. It says, in a study, the goal of the research was to determine if radio frequencies from cell phones increase the risk of contracting brain tumors. I don't know if you've ever heard that cell phone use, the electromagnetic waves it cause may lead to cancer or something. And that was described in the previous slide right here, cell phones and brain cancer. But the thing is that there are two variables going on. There is, do you use a cell phone, or how much do you use the cell phone? That's the explanatory variable. Okay, the explanatory variable that explains what's going on. The cell phone use is the explanation or the reason for what's happening. reason for what's happening. And then the response variable, response, that's kind of the, usually a response is the answer to the question. Okay, that's what is happening at the end. Okay, and that's whether you get cancer or not. Okay, so the response variable in this case is, like I said, whether you get, that's I'll say what happens in the end.
So really quick, explanatory variable would be like the radiation causing cancer, or would it be?
Yes, the cell phone use, the radiation, again, the explanation for it. We're trying to see if the cell phone use and the radiation is the reason for the cancer. So the explanatory variable, that's the cell phone use. So I'll just say cell use. And then the response is the cancer.
It wouldn't be like the result, like, okay, that what happens in the end, the result, or? Well,
Yeah, that's the results. Yeah, that's right. Yeah. And so,
like it would be like findings or results after the experience,
yeah. Let's say if we were doing a study on smoking, we all know smoking causes cancer. So smoking is the reason, that's the explanatory variable that explains the cancer. And then whether you get cancer or not, that's the response. So is smoking explaining the cancer? Kind of the idea. So I'm trying to use words similar to those definitions. Okay. Then there is, let's see, we have all kinds of definitions right in here. Let me go ahead and say, well, an observational study right here. If I were going to ask you what's the smart ass definition of that, you would say that it's a study where you observe, and that's what it is. If you're sitting out in the middle of Santa Ana College and you want to see what kinds of shoes or how many people wear Crocs, maybe you like Crocs because they're comfortable. People seem to fall into two groups. They either love them or hate them. And so maybe you're sitting in the quad there at SAC, and you just want to see how many people are wearing Crocs. That's an observational study. You're not giving them the Crocs. You're not doing anything. You're just sitting there observing. Now, the other end of that is to do an experiment, and that's where you apply a treatment.
And that would be whether you take away something, you add something.
Or maybe you're testing, let's just say, like a weight loss drug or a cancer treatment or something like that. So you're giving somebody a drug, or, a drug is an example, but to see, okay, if I give you this drug, if I give you this, or if we do this weight loss treatment, do you lose weight? And that's an experiment. So you have to apply something, not just sit there and watch. And let's see, we have different, there are different types of studies. And again, they're all good definitions to know. You want to, be real good as far as doing the homework, being familiar with them. I'm going to jump up to section 1.4 and types of sampling. I like census. That's a good one. Census is a good definition because, of course, we hear about that every 10 years. We do a national census, but a census in a statistical sense is just a study that involves everyone, the whole population. So if I put together a study that involved all SAC students, we would call that a census. And in fact, the school does do a census after the second week of class. That's when we report the attendance to the state, and then that forms the basis for our state funding, is who is in the class. That's why you can drop the class without and get your fees back and no W or anything like that within the first 2 weeks. But after we've done the census, and then we've gotten funding for you being there, that's where then we can't give the fees back, and you got to get a W and things like that. But a census, and then, yeah, and then I wanted to get to the types of sampling. That's actually in starts in section 1.3. We can, if I wanted to choose somebody to get an extra credit point, we can do a random sample, like put everybody in a hat and everybody's got an equal chance of being chosen. That's one way to do sampling. So let's see, there are actually 5 types of sampling. 5 types of sampling. Random. Okay, random is one of them. And then going a little bit further down, there's stratified. And what that is, and I'll write a little bit on that. Stratified, if I can spell that. Stratified sampling. And you can see the definition here is where you obtained by separating the population into groups and then some from each group. Okay, so stratified, you create groups and you take some from each group. Another type of sampling in a group is called systematic. And that's where it says select every kth individual from the population. So again, if I wanted to choose some people to get extra credit points, I might choose like every 5th person on the roster, something like that. Okay, so systematic. That's often used in industry. Like if you work for Dryer's ice cream, you might choose like every 100th quart coming off of the line or something. Systematic way. There's cluster sampling. And what cluster is where you have lots of little groups and then what you do is you sample some of the groups, the whole groups. And then you choose, I'll say choose, that makes a little bit more sense. Some whole groups, like everybody in the group. Choose some whole groups. And then wait a minute, stratified, systematic, cluster, and oh yeah, convenience. That's the last one. I knew there was another one. Convenience is just using whatever's easiest. Sometimes convenience, though, can be biased. It's cheap and easy. Like, if I was interested in the average age of everyone here at Santa Ana College and I decided to use you guys be a good group, but maybe not completely representative of the whole all the students. So that's where there can be a problem with that. Let's see. Yeah.
Can you kind of help me understand the differences between cluster and stratified? Because I'm kind of getting a little mixed up with that.
Super good question. Everybody does. I was expecting that. So I'm glad you stepped up and asked. Okay. Stratified, let me, let's see. Oh, I've got a neat graphic. Right, whoops, right there. You know what? And that doesn't look very big. So let's go ahead. Now, in stratified, like you take your population, you might, let's say, for example, if I divided the population into maybe gender, I think the pictures they show are gender. So let's say male, female, or any of the others. Anyway, so you divide into groups, and then you sample some from each group. So I'm going to take some males, some females, some non-binary, or, you know, however many categories you have. So people are divided into groups, then you take some from each group. In cluster, you got your everybody is divided into lots of little groups. So you can see here, like we have groups of 4. Our population is divided into little clusters, and you choose a whole group. Like everybody in this first cluster gets to be chosen. And then everybody in this group gets to be chosen. You often see cluster sampling on elections. If you hear the if you listen to the news, like on election day, sometimes they'll put news reporters at one polling place, and they'll ask everybody there at that polling place. And that's cluster sampling. Like, we're going to randomly choose a polling place. Okay, we're going to go over here and talk to everybody at that polling place. So you have lots of little groups, and you look at everybody in a group. That's cluster. And if we go back to stratified, stratified means you divide everybody into groups and then some from each group. So let me go back to what I wrote. And that's where I said stratified, you take some from each group, and then cluster, you have lots of little groups, and then you choose whole groups. Like, I'm going to choose everybody here and everybody over here and everybody over there. Does that make sense?
Yeah, thank you.
Cool. Then there are, again, some other definitions. Bias just means that there's something wrong with the data. Either it does not represent the population, or somebody made a mistake. Okay, so there's some sort of a mistake going on. Maybe you didn't take a big enough sample. You know, there's lots of things that can lead to mistakes. And then some of these others that I want to highlight, control group and placebo. Okay, when you often, if we, let's say we're testing a weight loss drug, we might want to have 2 groups. The control group is, they get no treatment. They're not going to get a drug. In fact, a placebo is what they get. They get a fake drug. So they think they're getting a treatment, but they're not really getting anything. And so those are definitions that you often hear in the outside world, is control group and placebo. And then, of course, you're going to have your treatment group, the treatment.
I always thought control group meant that one was the one that's like, they're trying out the medicine, for example. And placebo was like a sugar pill.
Well, you're right. The placebo is the sugar pill, and it's the control group that's getting the placebo. It's the treatment group.
Okay. Goes together.
The treatment group gets the real drug. So then you can compare them.
Oh, treatment. Okay. Treatment. That makes sense.
So that's where it says the control group, that serves as the baseline to compare the other treatments. So, okay, so we've got the people that aren't getting the weight loss drug. We're going to see, do they gain or lose weight? And then we're going to compare that to the people that really do get the drug and see what the difference is between them. And so then the rest of the stuff we will, again, they're good definitions. We got homework problems on them, but I just want to highlight some of those things, some of the definitions that we will be using in the future. And so, anybody have any questions? That's pretty much the highlights. In the future, I'm not going to go over things that super fast. But it was just to, again, kind of stimulate your memory. What we'll do in the future is in future days in the beginning, I will kind of give some highlights of what we went over before, and then ask you, do you have any questions? And then when we cover material, like a little bit later today, when we cover chapter 2, I won't be going over it this fast. Okay, I'll be slowing down a little bit and doing some examples. But again, the whole point of this was just to kind of at least let you know some of the more important definitions that we'll be seeing in the future. So anybody have any questions, thoughts, comments, issues, thoughts? All right. Well, tell you what, if we don't have any thoughts, then let me show you. Now I'm going to have to make some adjustments on the quiz, but I'm not. So what you can do now, if you go to your assignments on my lab, actually the quiz should be there. Now you can't take it yet, but yeah, look at that. Do you see down there on the bottom, it says quiz number 1. My plan was to give you 15 minutes, but now obviously it says right here 9:15, so I have to go change that. So just a second, we can't start yet, and well, you need a password anyway, so don't click on it. Let me change the whoops, geez, logged me out. Hold on. Take one moment. So what I'm going to do is I'm going to say like an official start time of like 9:10. In the meantime, could you turn on cameras, live video, and take care of that? I'm going to take roll while you're doing the quiz and double check who's here and everything. And so what I need to do is, if we call it 9:10, then it would be due at 9:25. Oh, wait a minute, just a second. I moved my notebook and it hit hit one of the keys on the computer. So what we'll do is, so the quiz is we'll go 9, like I said, we'll call it 9:10 to 9:25. Again, 15 minutes should be plenty. It's just 10 little multiple choice things, so that should be super you should you'll probably get done in 5 minutes. But anyway, so the password is, oh, before I get to the password, one thing again, no notes, show live video, and let's see, live video, no notes, use your brain, open brain, and you won't need a calculator or anything like that. And then when you're done, we'll go ahead and take a break. We'll take a 10-minute break. So the break will go from 9:25 to 9:35, and then we'll get started again. Okay, and so with that, good luck. Look at that. It is 9:10. The password is parameter.
Where I don't see the quiz. I just want to make sure before you go that
It should be, okay.
assignments, I'm on assignments.
Yeah, assignments, all the way down to the bottom.
all the way down at the bottom. See 1.4, 1.5, and then I see 1.2 media.
And you might need to refresh it because I did
Try it
just
again.
change
Okay.
it.
That sounds right.
See, now it shows the new due time of 9:25.
Okay, I'm gonna refresh.
So
Hmm.
best form of communication, well, during class is the chat. And then outside of class, pronto or email. I'm just answering a question on the chat. But anyway, good luck. If you have any questions, feel free to chat me individually. Please don't bother the whole class. If you have a question during the quiz, naturally, we don't want to interrupt anybody. So just chat me individually, and that is a really good way to go. So I'll pause the recording. All right. Well, I hope the quiz treated you okay. And if you had any trouble accessing it, we'll take care of that after class. Remember, I have an office hour right after class. So again, if you have any questions or concerns, please stick around afterwards. And what I'll do is I'll keep the Zoom active so we can chat and take care of whatever's on your mind. And then also, I realized during the quiz, some of you were chatting me, and I was missing some of the messages. Since there are two of me, and I put a little note there, if you message me using the John Zarsky host, okay, that's on my computer. The host is actually my computer on the left side. And then that's the one that I'm really watching. The other one, of course, is my tablet. And so if you do John Zarsky co-host, that's my tablet. And to keep my tablet screen clear, I'm not really looking at that one. Okay. Let's see. Oh, Brooke, I see your message right there. Yeah, why don't you stick around afterwards? Let's go ahead. Let's take a look at that. And it gave you 9 minutes. That's yeah, it should have given you 15. But anyway, we can take a look at that. So that's where, you know, I'm happy to work with you. And I do give, you know, some extensions on the assignments and things like that. Oh, Seth, I gave you 9 also. Well, there was a due date or due time. The time was the quiz was supposed to be done at 9:25. So conceivably, I don't know if you started late, but let me okay. Okay, I'm seeing the messages coming in. So like I say, if you had any troubles, stick around after class and we will figure it out. Okay, so that, yeah, I'm seeing gave you 9, gave you 7. Okay, that's kind of interesting. And Kimberly didn't finish it. Okay, anyway, that's why I said stick around. We'll figure it out. It will be okay. All right. I don't want you to go away unhappy. So we'll, like I say, we'll figure all that out. You can't hear me. Can everybody else hear me? Yeah, somebody says they can't hear me. Yeah, Safa, even though you took it already, yeah. Any concerns about the quiz? You stick around afterwards and we'll figure it out. Okay, Marlene, you're saying you can hear me. Great. Then one, if you can't hear me, try turning up your volume. But yeah, so I think my audio is coming. It sounds like it looks like my audio is coming through. Okay. Any other well, I say non-statistics, but any other quiz or technology or any concerns there? Anything else? Are we good? Everybody get a chance to get out, walk around? I did for just a moment. Yeah.
Where are you at? Hold up. I had a question.
Yeah, what's that?
Is every single time that we log into the quiz, is there going to be a random password that you give us?
Yes.
Okay. Okay.
Yeah.
Cool.
So you got to be here to get the password. And what I'll do is usually, you know, like what we just did, you know, I'll have it set up for a certain amount of time. and then I give you the password, and then it probably works best because I do change the settings right beforehand to accommodate whenever we start and end, to probably hit assignments or refresh your screen, and then go to assignments and the quiz to make sure that whatever changes I made, make sure that those take and that those are applied. Okay, so but anyway, we'll figure it out after class if there's anything, and I will, like I say, I'll take care of you. Main thing, you know, I try to make this as painless as possible, but you know, the main thing is, you know, as long as you guys are doing the work and everything, then that's the biggest thing. The two words of advice are certainly you gotta do the work and keep up, but then also get any questions that you have answered. And so that's where office hours are really good. So stick around and we'll take care of anything you need.
Do you
Okay.
Sorry.
Oh, no problem. Oh, looks like Juan is okay. Okay, great. Glad you're hearing. Anything else?
I wanted to also ask if we like, I know you said that you dropped the worst quiz
Yeah,
score,
the lowest quiz, yes.
the lowest quiz. It's just for the quiz, not test is different story, just the quiz, right?
Yeah, test is different. I philosophically don't drop tests just because it says, because like if we have 4 tests, that
Yeah.
basically says,
Makes
gives you
sense.
the message, or gives people the message that you can blow off 25% of the class, and that's not okay.
Makes sense. So what about redo quiz or something?
Well, I don't do redos generally. Again, yeah, it's pretty much you pretty much do it there. Now that's where, again, if there was a problem during like say, for example, a technological problem or my lab problem, or let's say, for example, my internet goes out. Okay, if something weird happens, then I adjust and we figure it out. Again, you know, I'm not looking for you guys to get I'm not out to get you guys. I'm out to help you guys get through this class. And
Okay.
so again, that's where I take care of special things on a case-by-case basis during office hours, and that's what I say, we figure it out. That makes sense?
Yes, perfect. Thank you.
Cool. Awesome. All right. So let's go ahead and start talking about chapter 2. Now, again, ideally at this point, I know I assigned, ideally, you should have seen the medias for 2.1 through 2.4. So I'll even write that down. Ideally, at this point, you should have done medias 2.1 through 2.4, and then 3.1 and 3.2. Okay, so again, the medias are all about prep for the actual sections of 2.1 through 2.4 and 3.1 and 3.2. But I know that, like I say, this week was a crazy week. We hadn't met already, lots of things going on. And so it's with that, I've pretty much extended everything. I'm going to give a little bit of an overview, not quite as crazy fast as the chapter 1 that I did earlier today, but there'll be kind of an overview with the idea that I'm going to kind of tickle your brains a little bit or plant some seeds to where then when you do the medias as part of the assignment, weird things coming up on my computer. When you do then when you do the medias, then hopefully it'll all make sense. You do the homework. If you have any trouble doing the homework, message me. You can message me either through email or Pronto, and I'll answer your questions, or you can see me during office hours. And so there are lots of options. You can also go to the Math Center. So, but the main thing is that you'll have to do a good chunk of work between the times that we meet, and hopefully not wait till like the night before. Okay, kind of pace yourself throughout the week. So for example, we got a bunch of stuff that's now due in 2 weeks. So again, just pace yourself to where you're working on it, and then it'll be okay. Don't wait till the last minute. That's a problem. All right. So let's go ahead and, as you see right here in chapter 2, it talks about organizing and summarizing data. And you can see here in section 2.1, it's organizing qualitative data. Now, if you remember, I'm sure you remember every single thing that I say. And I know realistically we don't. So what I'm going to do is, again, refresh your memory a little bit. Remember, qualitative data, those are qualities or labels or categorical data. So we're looking at how to organize categorical data. And so, and again, thinking about this, if I gather all kinds of information on you, let's suppose I passed out a survey today and I ask you, well, what's your major? I'm not going to just leave that information sit in a pile on my desk. All right, we got to organize it somehow. And so these kinds of things you've seen quite a bit, I'm sure, in the outside world. Because yeah, when data is collected from a survey or an experiment, you got to organize it in some sort of manageable form. And so we sometimes will organize data, you can see here, in a table or a graph. And so we're going to see some examples of that kind of in the homework. And so, so let's take a look at the next slide. We have something called a frequency distribution. Now that is a new definition for you. So I want to spend a few minutes on that. A frequency distribution tells you how many things, it's a table that tells you how many things are in each category. Tells you how many things in each category. And you might be thinking, okay, Mr. Zarsky, what do you mean by that? What are you talking about? Let's suppose, for example, I've got test scores. And the test scores, you know, maybe there are 8 A's and 10 B's, 12 C's, and maybe 5 D's and 2 below that. Okay, so maybe for a total of, I don't know, how many is that? That's about 37. Okay, so if I were going to make that into a table, okay, so a frequency distribution, if we take that data, frequency distribution of this would be that we have our categories or the grades. So we got A, B, C, D, and F. And then how many? Frequency. How many in each class? All right. So what are there? There are 8, 10 B's, 12 C's, 5 D's, and 2 below. Okay, so again, a frequency distribution just tells you how many things are in each category. And the word frequency means how many. All right. So now frequency, again, you see the word frequency and it means how many. Now, one thing that you'll also see here in this class, and you see relative frequency. Now, relative frequency, what you want to think there, think of like percent. So you see right here, it says the proportion or percent of observations within a category. And then you might be thinking, okay, wait a minute, Mr. Zarsky, how do I calculate a percent? If you wanted to calculate a percent, you have, and I have like the little formula right here, you have the how many, that's frequency, over the total. So if I wanted to do what we call a relative frequency distribution, let's write that down. Relative frequency distribution. We would still have the same categories like the grades. But then, okay, so we would have A, B, C, D, and F. A, B, C, D, and F. And then we would have what we call relative frequencies. And again, in your mind, you want to connect relative frequency with percent. Because if you want to calculate percent, you take how many out of the total. Okay, and so for example, with the A's, the relative frequency would be 8 out of 37. And we can go ahead and whip out a calculator and get a decimal approximation for that. 8 divided by 37, that would be about 0.22. I rounded to 2 decimals, 0.22. Or you can shift the decimal 2 places, that would be 22%. All 3 of these, okay, I'm changing my highlighter color here a second, okay. So all 3 of these, whether you do a fraction, decimal, or percent, are all relative frequencies. Okay, so let's do that with the rest of them. 10 out of 37 for the B's, there were 10 B's out of 37, so 10 divided by 37, I'm doing that right now, and that's 0.27. Or about 27%. The C's would be 12 out of 37. That's about 0.32. So 12 out of 37 would be 0.32, or about 2%. Then the D's, that's 5 out of 37. That's about 0.5 out of 37 is about 0.14, or 14%. And then the F's, that was 2 out of 37, which is about 0.5. 05, I mean, 0.05. It's about 5%. Now, hopefully all these percentages add up to 100%. If they don't, it's because of rounding. But I'm just going to, since I made up this example, I'm going to add these up just to double check. 27 plus 32 plus 15 plus 5, and it does add up to nice 100%. Okay. Now, relative frequency, again, it's like say a percentage. What it is it's how many relative to the group. So again, a percentage is how many you got relative to the whole group. And so then what we can do with these, we can do a bar graph. So on the next slide, a bar graph that's constructed by labeling each category, and then you can have the frequency, which is how many, or relative frequency on the other axis. So an example of a bar graph with this same data, we can mark it off with the A, B, C, D, and F, and then mark it off with the how many, and I forgot how many there were. Oh yeah, there were 8 A's, so it's 8, 10, 12, 5, and 2. So let's mark it off maybe in twos, 2, 4, 6, 8, 10, 12. Okay, and then we would just have a bar. Well, for the A's, there were 8 of those. And then the B's, I think there were 10. The C's, there were 12. And the D's, there were 5 and then 2. Let's see, 5. And 2. And we can color them to make them look a little nicer. Okay. Bar graph. Okay. And now a bar graph can also be called a Pareto chart. So bar graph this is for qualitative data. See if I can spell qualitative. Is also called a Pareto chart. That's on the next slide. Okay. Now, what I want to do for a moment, what I like to do is sometimes refer to the book. You might ask, well, do I have to buy the book? No, you don't. I think, oh yeah, what I remember hearing for this class is that when you get MyLab Access, I think after you pay for it, you can request a loose leaf book. So it can include the book. That might be through the bookstore. I think I sent some information on that. Wasn't there? Didn't I do an announcement? I've done so many announcements in all my classes. Now they're all kind of mixing together. But let me bring up the book, the e-text. So by having MyLab Access, you have access to the book. And like say, for example, we can look at various bar graphs, and it's taking time to come up. While it's coming up, anybody have any questions so far? Is it okay? Book is a good resource. Lots of good examples here. You can see some bar charts here. And again, various categories. And I forgot what these body parts are about, but you can see the how many. The bars look at how many. Oh, the type of rehab. And then you could also have the relative frequency. Often the relative frequency is just the decimal version. Okay, but they still have the same shape. You can see the bars are the same. And then, so you can also do what you may have seen in the outside world. Sometimes I see things if you want to compare two types of data. We can do a side-by-side bar graph, which should be showing up here on the screen, and it's running slow. And while it's coming up, I just want to say that, you know, my internet usually is pretty good, but there have been times where it's gone out. Let's see. Okay, this is, there it is. Now there've been a couple of times, like I say, where my internet has gone out. And if it goes out on both computers, watch pronto. I'll get right on my phone and send you a message. Updates. Okay, and then somehow it jumped pages. Okay, so page 72 in the book. You can see like a side-by-side bar graph where you can compare two things. In this case, educational attainment in 1990 versus 2017. Okay, so compare two groups. And pie charts, I'm sure you've seen pie charts. Everybody's seen pie charts in some way, shape, or form. But a pie chart, I'll show you the slide in just a second. You can see a pie chart of educational attainment. Now, a pie chart is always a percentage of the pie. You have the piece of pie that shows percentage. And so the pie, you know, that you're used to seeing as always showing percentage, of course it always does, but to use one of the terms that we've talked about, it uses relative frequencies. So let's see, I've got a slide on pie charts here, just a second. There we go. It says pie chart is a circle divided into sectors, and each sector represents a category of data. The area of each sector represents the relative frequency or percentage. Okay, and so one thing to note is that pie charts are always for qualitative data. And you can see in this example in the book, I'll move the PowerPoint just a moment, and you can see that in this example, it is the educational attainment, and that is qualitative or categorical data. Okay. Does that make sense? So then, I don't know, any questions? Can you think of anything? Now, after this, now what you would do again, if you've done the media assignments, great. If not, you go right into my lab, you do the 2.1 media. That kind of goes through in a little bit more detail of what I've talked about. And then you would do the homework for 2.1. All right. Oh, question. Yeah. The PowerPoint slides are in my lab. Oh, thank you, Jasmine. Yeah, they're under communication tools, document sharing. Pretty much just about everything is in, as far as the statistics, is in my lab. In fact, sometimes, you know, you're used to finding your grades on Canvas. Your grades are in my lab. Okay, so I have pretty much Canvas is a nice, I need to use Canvas, of course, so that we can use the Tech Connect to get on Zoom. That's where I put the syllabus, and that's where I put the recordings. And that's pretty much all that's in Canvas. Everything else is here in my lab. Okay, is that good, Marlene? All right, okay. Cool. And again, the path to get there is communication tools along the left side, and then document sharing. And then the files are there. All right. Okay. I'm going to go ahead and go on to the next section. unless there are questions. Now, you might think, okay, if 2.1 was about qualitative data and the categories, then all right, then we go from there and we go to quantitative. And if you were thinking that, then you are correct. Because remember that quantitative data, we remember that those are quantities, that is numerical data or number data. All right. So with numerical data, we can do a lot of the same things. And I actually have some examples right here in the PowerPoint. Okay. So if we have a bunch of numerical data, like on the next slide, I'll just show you. Look at all those numbers. Isn't that fun? We'll talk about those in a minute. I'll come back to that. So the first step in summarizing quantitative data is determine whether the data is discrete or continuous. Remember, discrete, lots of decimals don't make sense. The decimals gotta stop. More decimals don't make sense. Or continuous. So if the data are discrete, then there are relatively few different values of the variable in the categories. And the categories of the data we call classes. And then there's the data, okay, and how many fall into each class. So if we have numbers, let's go over to here, and it says a random sample of 50 households, and it says construct a frequency and relative frequency distribution. Those are the same things that we just talked about. Remember, frequency distribution is how many are in each category. So what we would do is we would take those and figure, okay, how many zeros, ones, twos, threes, fours, and fives. And then you can see we have how many. And so a frequency distribution, when we're talking now, we're in section 2.2, a frequency distribution is where you're going to have the classes 0, 1, 2, 3, 4, 5, and then the frequency is the how many's. 4, 13, 22, 7, 3, and 1. And then, of course, you can see relative frequency right there. That's like a percentage. That's the how many divided by the total. Okay. Now, just like before, just like what I did right above here in the notes, you can see I've got the bar chart or the Pareto chart, the bar graph. When we have numerical data, we have a different name for the bar graph, and it's called a histogram. And you can see that right there. Histogram is constructed by drawing bars for each class. The height of each bar is the frequency or relative frequency, and the width of each bar is the same, and the bars touch each other. No spaces between the bars. So basically, a histogram is a bar graph for quantitative data. Now, we have some examples, and I'm going to show you on page 85. So let me go ahead and go back to the book. So you can make a little note, page 85. And you can see right here that they look at parking fines for or fines for parking and camera violations in New York City. So you can see how the bars, for example, how many fines were there between $100 and $125? There were 7 of them. And now you might wonder, wait a minute, Mr. Zarsky, what if the fine was $125? Does it get counted in this group above or this group below? Okay, so typically the way the bars work, like for example, if we're looking on page, again, this is page 85. So we looked at the example on page 85. But the classes would go from, say, for example, from 100 to 125. But what it would do, typically what it does is that it includes the 100, it includes the lower value, includes 100, and everything up or below, I'll say that's a better word, everything below 125. So then the next category would go from 125 would go into the next one. So 125 to 150. And again, everything below 150. And then once you hit 150, then you go to the next bar. Okay. So let's see. Let's talk about some other pictures. Histograms are important. You need to be able to read histograms now, and you'll see that in the homework. I've talked about classes. Classes, those are the categories that you see. I have another example on the next slide. And you can see here, it says the following data represents the number of persons aged 25 to 64 who are currently disabled. Okay. Now, if you look at these classes, there's no ambiguity because you see 25 to 34, and then the next class jumps to 35 to 44. You don't see kind of, the classes butted up against each other to where, if you have 34, you know which class it's in. If you have 35, you know which class it's in. And so that's another way that we can set up our classes. But what you see here is we've got a couple of definitions of lower class limits and upper class limits. The lower ones, that's the 25, 35, 45. And then the upper class limits, that's the 34, 44, 54. And then the class width, if I were to ask you what's the class width, you could give me a smart ass answer and say, well, it's the width of each class. Yeah. Okay. So nothing real special there. All right. And in the homework, again, you're going to get to look at some histograms. I've got another example of one here in the PowerPoint. And this one has to do with time between eruptions of a geyser. So I don't know if y'all have ever seen a geyser, but up in Yellowstone National Park, they have these, well, it's kind of volcanic over there. It's kind of a volcanic area. And when water seeps down in the ground and hits the hot stuff under the ground, it blows up and blows water in the air, and it's kind of cool to see. And that's a geyser. So anyway, examples of histograms. Another type of picture that we make is something called a dot plot. And a dot plot, okay, you might say, well, wait a minute, what's a dot plot? All right, let's look at it. It says a dot plot is drawn by placing each observation horizontally and in increasing order and placing a dot above the observation. And then you're like, what? All right, let's look at an example. That's on page 86. So what you see here, an example of a dot plot, and it says a dot plot of arrivals at Wendy's and how many customers, the number of customers. And so you can see a dot represents let me understand this data. Hold on a second. What is that talking about for Wendy's? I forgot. Page 86, just a second. All right. Oh, table 8, that was page 81. That's where they originally get the data. Oh, what it says here, it says the manager of a Wendy's fast food restaurant wants to know the typical number of customers who arrive during the lunch hour. And the data represents the number of customers who arrive for 40 randomly selected 15-minute intervals of time during lunch. For example, one 15-minute interval, 7 customers arrived. And yeah, so for one of them, for example, during 157 customers arrived, construct. So then, so for so I'm guessing what this is for each time interval. And then for the 4th time interval, there were 4 customers that arrived. So you have a dot plot for each one. And so anyway, do you spend your time drawing dots? No. We don't usually do this, like draw them. What we do is we will use technology. And in fact, that leads us to, you might ask, well, do I need a calculator? I think in the syllabus, I said you need a scientific calculator, and I actually should have changed that because what we do here with Zoom, we're going to go ahead and just use the technology that's contained within MyLab, and that is called StatCrunch. So let me just take a quick little, I'm going to take a break from what we're talking about here in math and just show you where StatCrunch is. StatCrunch is along the left side. You can see it right here on mine, and that is what we'll be using for doing calculations. So if we click on StatCrunch, it'll take us to another link, StatCrunch website. Open StatCrunch, and then we can use it to calculate things. Now, I'm going to say a little bit more about this a little bit later today when we do a little bit of chapter 3. Chapter 3 is where we actually get into the math. Okay, but one of the things you can do with data, like for example, if I go to a graph, you can see a lot of these things that we've been talking about are right here, like even a dot plot. It will create a lot of these pictures for you. All right. So in case you were wondering, so you don't need to worry about the scientific calculator. I had that in there originally in the syllabus when we were going to do on-campus live testing, and we're not going to do that now. So since everything is on MyLab, we don't need to bring a calculator to class. We're going to be online. Okay. All right. So back to the PowerPoint. Okay. And you can see right here, it says, now this slide is kind of important. Okay, there are 4 ways. So I'm going to say notes for slide 21. There are 4 ways to describe a set of data or describe the shape of a set of data. And so 4 things, and you will see these in the future. So I'm going to highlight these as important. Now, uniform, the definition, it says the frequency of each value is evenly spread across the values. What that means in English, when you're looking at uniform, think of a flat histogram. Everything is the same. Histogram. And I have examples of these on the next slide. So for example, if I go to the next slide, and you can see uniform right there. Everything is the same. The same number, same amounts of in each. Okay. Then bell-shaped. Bell-shaped is, well, the smart-ass thing is it's shaped like a bell. Okay, it's high in the middle and low on the sides. Now, the thing about bell-shaped, what we're going to see later in the future, we often call this normal. If something is normally distributed, we say it's bell-shaped, and you can see the example of that on the next slide. And the second one, we would say, because see if I draw like a little bell right here, bell-shaped or normal. All right, high in the middle, low on the sides. Then the other 2, you can see, are skewed right and skewed left. Now that means that it's kind of out of balance, like all the data is toward one side or the other. Now, when we say it is skewed right, that means that the tail or the low end goes to the right. Look at the example. See, look on the skewed right picture right here, and the tail goes to the right, the low end of the data. Sometimes you want to look at, well, wait a minute, most of the data is on the left. Don't we want to call that skewed left? No. No, skewed right refers to the tail, where the data trails off. So the same is true for left. That means, again, the low end of the data, where the tail of the data is going. Okay. That's 2.2, pictures of data. We've got 2.3 is more pictures of data. We're going to talk about that in just a moment. But before we do, anybody have any questions? Anything strange, unusual? All right. Okay. Then 2.3. We've got some more pictures. Now, these pictures are, you probably have not heard of these pictures right here. In 2.2, like a histogram or a bar graph, pie charts in 2.1, some of these other ones that we've talked about, you may have heard of. But here, stem and leaf, time series, and even frequency polygons, cumulative frequency. Those are some new ones. So we're going to talk about those just a little bit and what they mean. As far as the ogives, that's the 4th objective right there. we're kind of skipping those. There should be no homework asking you about ogives. All right, so we're kind of skipping that. So the first thing you might be wondering, Mr. Zarsky, what's a stem and leaf plot? Well, I'll tell you. All right. It says here, a stem and leaf plot uses digits to the left and the rightmost digit to form the stem, or use digits to the left of the rightmost digit to form a stem, and each rightmost digit forms a leaf. And again, you're probably looking at that thing and, okay, Mr. Zarsky, that is like clear as mud. Okay, I do not get what you're talking about. Okay, what that means, we need an example. So let me give you some data. So there's about, there's several things. I forgot how many there are. So there's probably about 10 things here. So let's write them out. So we got 50, 52, 54, 63, 3 times, 71, 74, 78, and 79. So what is that? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, about 10 things. Okay. So when we do a stem and leaf plot, it's kind of cool. It's easy to do and it's kind of cool. And I'll show you what we mean. The stems, those are left digits. And the leaves are right digits. And again, you're probably thinking, what do you mean? Okay, well, if we look at this data, what are the left digits we see? The left digits we see, I'm sure you see 5s. Okay, yeah, you see the left digits, those are 5s. And then 6s, 7s. So the only left digits we see are 5, 6s, and 7s. So those are our stems, 5, 6, and 7. Okay, then what are the right digits? So for the 5s, we see 0, 2, and 4. And so we would go ahead and write those down, 0, 2, and 4. And you're thinking, okay, so then that row means 50, 52, and 54 when you put the left side and the right sides together. So what this is kind of a neat way to summarize the data, but not have to write everything out. So let's do the 6s. Or the 60s. Oh, let's see. We got, I guess we have 3 3s. So we're going to go 3, 3, and 3. Then for the 70s, we got 1, 4, 8, and 9. And then now you're like, that doesn't look really cool. Mr. Zarsky, you said that this was cool, and I'm not seeing any coolness here. This is weird. Okay, what's neat about this is it's a quick and dirty way to summarize the data and make a picture. I'm going to write that down. It's a quick and dirty way. I say quick and dirty because you don't want to share it with anybody else because nobody else understands what you're doing. So it's a quick and dirty way to not only summarize, so you can summarize and make a picture of the data. Make a pic of the data. And you're like, wait a minute, what do you mean? Make a picture of the data? Well, look at what we got here. It's almost like a histogram on its side. Okay. So that's where it's like, oh, that's kind of interesting. All right. So then if you're gathering a bunch of data, in fact, I do that with test scores. When I have a set of test scores and I want to summarize it, and I want to look at how many A's, B's, C's, I do something like this. And so, like I say, a stem and leaf is kind of again, I call it a quick and dirty way to summarize and make a picture of the data. It's not something that we show the public. It's just a quick way to see what's going on. All right, because most of the public doesn't even know how to read it. So then let's see. We have the next picture to talk about is something called a frequency polygon. Now, frequency polygon, I'm going to write a little note here. You can write it on the slide if you've got it. I don't have enough room. But a frequency polygon basically, this is going to sound like a weird description, but you'll see what I'm talking about. It's like a histogram, if you replace the bar with a dot in the middle. If you replace the bar with a dot in the middle. And connect the dots. And you might be thinking, okay, I'm not seeing that. Well, I've got a picture. Then you can see that. Okay. So what this is this is actually, remember, I actually showed you the histogram for this time between eruptions for a geyser. Now, what this was is it had a bar. Whoops, I'm going to do it in green. It had a bar. The bars went like this. So that's why I said instead of bars, you have a dot in the middle where the dot is. That's the height of the bar. They take the bar away, put a dot, and it's in the middle of the class. And then they connect the dots. Now, let's look at this, that bar that we drew. You can see that 675 is the midpoint. Midpoint. So can anybody tell me what that class is? Where does this bar start and end? Anybody tell me, where does that bar that's got 675 in the middle, where does it start and end? Well, it's going to start right in the middle, like where I drew it, between 675 and 665. So what's right in between 675 and 665? Anybody want to help me? I'm thinking 670.
671,
or 670. Yeah, we would say 670. And then the upper limit.
What would it have? Would it be exact 670? Could I estimate to 671 since we don't really have exact?
Well, everything is evenly spaced. Whenever you do a histogram, or in this case, they took the histogram and made it into a frequency polygon, everything is evenly spaced. And so the midpoints are all evenly spaced. And so, yeah, so it would be 670 to 680. Okay. Now, one thing to note, and I think this might be a little bit of a question on the homework. In fact, maybe I should look at an example in the homework just to make sure. But typically, again, the limits, like for example, this is on slide 26. If you were going to look at the classes for each bar, they would go from 670 to 680, and then 680 to 690. You know, all the values that are right in the middle, and then 690 to 700. And so on. Those would be the classes for each bar. Now, one thing that we had earlier, and that I'll kind of specify right now, if they ask you about class limits, those were those upper class limits and lower class limits that we talked about. Usually what happens is you set up a little bit of a gap. You would go from 670 to 679, and then 680 to 689, and then 690 to 699. You build in a little bit of a mathematical gap between them. When we do histograms, that's why I say classes for each bar. In histograms, there are no gaps. Okay. So something that you might want to keep in mind for the homework. Okay. Oh, let's see. Jasmine, you have a question. Does it only apply to double digits? Oh, is that back? I'm sorry, I think I missed your question. Was that back on
yeah, it was for the stem and leaf plot.
The stem and leaf, yeah. You can have 3 digits, and in fact, let me just go back 2 slides right there. Now, if you have 3 digits, like I have this example right here, and it says if you have 147, then 14 would be the stem and 7 would be the leaf. So you basically, what you do is you have to split your data into left digits and right digits. So the left digits would be your stems, and then the right digits, whatever they are, would be your leaves. And so let me see. There's some more examples. We'll go back to that briefly. Let me page 94. Let me show you another one. Let's see, go back to the book. Page 94. And here you see percentage of persons living in poverty according to state. And what they do, you can see now what they do is they divide it into the left digits are everything to the left of the decimal, and the right digits are the first decimal point. So like the first, it says here, like the lowest value is 7.7. So that way, the way that appears in the stem and leaf is you've got 7 is the left digit, and then the 0.7. And then so like down here, like 9, this is 9.6, 9.5, 9.3, 9.5, 9.7. So you can kind of see, again, you pretty much have to divide, okay, left digits, those are my stems, right digits, those are my leaves. And then again, it just kind of gives you a nice way to summarize the data. And then you see the numbers themselves create a picture of the data. Does that clarify?
Yeah, thank you so much.
Okay. Oh, Vincent, yes. Would it be the same for a 4-digit number? Yes. If depending on what you, as a statistician, you have to decide, okay, if you had a 4-digit number, maybe the left 2 digits and then the right 2, or maybe the left 3. Again, it depends on how close your numbers are. And that it brings up an interesting point that I like to tell you all, is that statistics is part art and part science. The math, there's the math that say, here's how you do this, but depending on when you're the statistician, you try to choose a picture. I'm giving you all these different pictures, but sometimes you have to choose the picture that, conveys the message that you want. And so a lot of times there's not one set way to do something or one set picture you have to use. It's a matter of, choice. That's where I say it's part science and part art. And so, you make some decisions along the way. So, all right. And I see another question, Sam. Looks like Wi-Fi went out for a second. Yeah, that's one reason why I record these lectures and post them, because I know people's Wi-Fi goes out. Usually mine goes out at least once per semester, and so all kinds of weird things happen. So that's why I record them. You can always go back to the recording and see what happened if for some reason your technology dies or something weird happens. Okay. Now, the next thing is cumulative. We did the frequency polygon. Let's see. The next thing is cumulative. There we go. Cumulative frequency. Now, if you remember, I don't know if you know what cumulative means, but it means pretty much your total up to a certain point. Okay, and there is an example of this on page 98. And in fact, I saw a really cool example recently. I don't know if any of you follow basketball, but LeBron James just recently became the all-time leading scorer in basketball, scored the most points. He beat Kareem Abdul-Jabbar's record that's been in place for about 40 years, and scored like more than 38,000 points. And what was neat, and I should have saved it, but it was a neat graph showing over the years LeBron's total points and versus Kareem Abdul-Jabbar. So again, that's a cumulative distribution. That's on page 98 in the book here. And you can see, what the graph is. You can see parking fines, and it always goes up because what it is it's a cumulative total. Let me show you what I mean. Okay, so let's suppose you have your classes. That's the fine, like in the first class, goes from $50 to $74.99. And there was one of those. Okay. What you do for a cumulative frequency is you say, okay, what's the total that I've seen up to this point? So far we've seen 1. We go to the next class because that's 0. We still have only seen 1. We go to the next class, and at this point, the total is 8. So again, cumulative means the total up to a certain point. When we get to this class right here, it's the total of the 10 and everything before. That's where they get the 18. And then go to the next class. The total of that is now 23. So cumulative frequency is how many up to that point. Okay. And then the next one that I want to look at is a time series, and we see a lot of these in the outside world. because what a time series is, and I'll show you that, is data over time. And so very often in the news and things, we might see gas prices over time. They went up for a little bit, then they kind of gone down. You might look at stock market. In this case, they look at partisan conflict index in the United States, which I think that's kind of an interesting number. If you've you know that now, okay, it seems like both parties are really kind of at each other and arguing, and there's lots of conflict. Well, there's a number out there that measures how much conflict there is over time. And so, in fact, you know what, just for kicks, I think I'm going to go ahead and just Google that and say partisan conflict index, and let's see what it says. It should show us a neat time series of what's going on over time. And look at this. You can say, wow, I thought it was really bad now, but apparently it was really high in April of 2017. And then the conflict index kind of went down in April of 2020. That's kind of interesting. That's right about when COVID was getting really interesting. And it sounds like they were all on board. And then they started arguing more and more with each other. And you can see that over time, the conflict has gone up a little bit, but not as bad as it has been in the past. Let's see, where is it here? October 2013. I wonder what was going on that was causing that. But anyway, so anytime you see a graph over time, that's called a time series, and we see that all the time in the news. So that one's kind of fun to talk about. Now that's pretty much section 2.3. And now 2.4 is kind of a fun section, I think. And well, I don't know if you consider any of these sections fun, but in 2.4, we talk about the dark side of statistics, I guess is what I would say. The dark side is misrepresentation, or making mistakes, misrepresenting the data. And so you only have a few questions. This is a relatively short section on ways to misrepresent data. And so one example that we have here is if you look at both of these graphs, they both say the same thing, but they really convey a different message. And you can look along the vertical scale. This is life expectancy of people. Okay. And if you look at the first graph, they have the same points, but look at that. The first graph, you could say it might be Fox News saying, hey, the life expectancy of people has gone up. Look at that. Wow, it's going up. And then the second graph, again, same data. You might be saying, it's gone up a little bit. Why are these graphs so different? Can anybody see the difference? I mean, I've told you that it's the same data, but they look so different. What is it that is different between these that makes them look as different as they do? Can anybody see why?
The numbering on the vertical axis.
Exactly. Look at down there on the first one. Where does that vertical axis start? It's 68. So what you're seeing is a very narrow bit of the data. You're seeing where it increases. So you're like, hey, all right, big increase. Whereas the second one, you see the whole picture. You see everything starting from 0. Okay, and that's one way that you can misrepresent the data is basically it's a manipulation of the vertical scale. And you're not, both are reporting the same numbers, but they convey a very different message. And one other thing that you're going to run into is just, I've got an example here, is where you have a deceptive graph. And like this 3D graph, I'll write this. This is a deceptive graph. The 3D-ness of the graph looks good. It looks kind of cool, but it's really hard to get a perspective of this pie chart because that piece of pie right in front is getting most of our visual space. The better way to do it is just, again, to look at it from above, and then everything looks better. So we'll say not misleading or not deceptive. Okay, so you get some problems, so just a few exercises. In fact, I think only like 3 or 4 where they just ask you some questions about some deceptive graphs. And so like, for example, I'll just show you again. There's, let's see, I think like 1, 2, 3, yeah, like 4 different things, 5. Okay. And they basically have to do with either deceptive graphics, like what I just showed you, or somebody messing with the scale. Right? So I'll tell you what, let's go ahead and take just a little bit of a break until 11 o'clock. Again, give you a chance to walk around for a moment. And I'm going to go ahead and pause the recording. And let's say break until 11 o'clock. And then I'll say a few words about 3132. So break until 11 o'clock. Now, that doesn't mean leave. I just heard somebody leave. But anyway, okay. So go ahead. I'm going to pause the recording. And I'll be right back in about, at 11 o'clock. Okay, well, that was a nice break. We did a little bit of chatting. And so you can see here now, chapter 3, it says numerically summarizing data. And we get to do a little bit of math, and don't be afraid. It's not going to be any algebra. We're not going to be solving for X or doing the quadratic formula or anything like that. What we are going to be looking at here, like you see right here, chapter 3, it says numerically summarizing data. And so with that, before we get into that, I want to tell you about what I call the big 3. Now, notice the color, okay? When something is in red, if I use the red pen, that means it's an important topic that you want to know, because guaranteed to be on the test somehow, way, shape, or form, or just a critical concept for the course. All right. So if you look right here, and it says the big 3, what these are, this is the 3 main bits of information for describing a set of data. Okay, and we've started talking about them. We talked about the first one in the shape of the distribution. Remember, we talked about the 4 ways to describe a set of data. That was the uniform, bell shape, skewed right, skewed left. We've talked about that so far. And then the next 2 are going to come up, well, today. And so you see the shape. We've talked about that. Then the next thing is talking about a measure of center. Some of you may have heard about an average in an old math class. You might have calculated an average. Well, that's an example of a measure of center. We're going to talk about that. And then what the book calls a measure of dispersion or a measure of spread is the next one. So Now, what I want to do is just for fun, okay, I want to show you a problem way later in the book. Take a look. I'm going to jump way up in the future. And page 374. So this is way up there. 374, just problem number 29. I just want to show you how the big three characteristics kind of come into play later. That's why it's red, because again, you're going to see these things. So look at, say, for example, you got this problem, like look at this problem number 29. It says the length of a 4-year-old male upper arm is approximately normal. Okay, normal means bell-shaped. Remember, that's the shape. That's the first of the big three. Then they say that the mean is 21.8. That's the second of the big three. That's the middle. Then the third thing, standard deviation. That's a measure of spread. We're going to talk about that today. So right off the bat, when we have a set of data, those are the first three things we want: the shape, the measure of center, and the spread. And so that's why I started calling those the big three, just because later on, that's what they're going to give us. And then they're going to ask us questions about that. Okay, what to do. But when we have those three things, we can do a lot. Okay. So let's talk about now, again, 3.1 is the measures of center. And they say right here, measures of central tendency. Okay. There are three main measures of center that we are interested in. And that's the mean, median, and mode. Okay, so we need to know what each of these are. So this is section 3.1. And so I'm going to, let's talk about the mean first. Okay, so the mean, or the average, what that is that's where you sum, take the sum of all the data, and rather than use sum, maybe I'll just say add all the data. And you divide by how many? Divide by the number of things you have. That's the average and the mean. All right. Now, the we have two different means right here, and this goes to a definition that I talked about earlier. If we're talking about a population mean, that's a mean for the whole group, the whole population. Remember, that's a parameter. Circle that word parameter. And then if we have a sample mean, that's because it's part of the sample, we call it a statistic. Now we have special symbols for each one, and you can see them right here. For the population mean, it's the Greek letter mu. It looks like a fancy U, pronounced mu. We learn a lot of Greek in here, and we use some Greek letters, and we're going to talk about some more Greek today. But then the symbol for a sample mean is X bar. And that's where I say it's pronounced X bar. It's just a bar with an X over it. So if you see the, again, let's say, for example, if we're talking about the average age of SAC students, if I use the symbol mu, which is, again, the fancy U, you can kind of see how I draw it, kind of a U tilted a little bit to the right with some tails. If I say mu equals 23, then again, because of the mu, that's saying that's the whole population. And if I say X bar equals 24, that means that I'm talking about a sample. Okay, so we have two different symbols. So which symbol we use tells people what that number represents. Okay, so now on the next slide, we need to understand some more mathematical symbols. Now the average, like I said on the right, and I'll highlight it right there, is you add all the data and divide by how many you have. And that's the same whether you are talking about a population or a sample, like you see on this slide. What I want to point out is some of the notation, and that's the silly little symbol right there. What that is a Greek letter sigma. And in math, it means sum. So when we see the letter sigma like that, and it says then there's that sigma x, what that means in English is the sum of all the x's. So we'll see that sigma symbol around from time to time. And so we have to know what that means in English. But basically, both of these formulas say in symbols what I wrote on the right side and highlighted, where you add all the data and divide by how many. Then you might be wondering, okay, Mr. Zarsky, why does one of them have a capital N and the other one have a small n? Well, the capital N typically represents, we let that represents a population size. So capital N is the size of the whole population. So if we're talking about Santa Ana College students, that would be all 30,000 students. A little n is pretty standard for us. That's the sample size. So that's why you can see there's a capital N with the mu, because we're talking about a population. There's a little n for the sample size. Okay. Now, let's go ahead and have some fun. For example, suppose we have 80, 82, 85, and 89. Those are just four numbers. And what I'd like you to do is just open up StatCrunch. Now, remember how to do that. I'm going to go over to, I'm going to do it again here. Let me close a couple of those windows. What you want to do is you can switch over to My Lab. And when you hit StatCrunch along the left side, StatCrunch website, open StatCrunch. And what we're going to do is we're just going to put those numbers in. 80, 82, 85, 89. And then you go to statistics. So you want to write this down, statistics, summary stats, columns. Click on the column, compute. Bam, look at that. It gives us all kinds of fun stuff. Gives us a mean right there. Look at that. The mean is 84. That's the average. So let's write that down. So we went to StatCrunch. So for the mean, we got 84. And what we did is we went to StatCrunch and then went to summary stats, columns. And then you highlight the column you want. And you can see when I go ahead and do that, it brings up the label of the column. Let me show you what that is. Notice the labels in the columns, the column labels. It says var1, var2, var3. The only column we have data in is var1. So that's the only option right there. We select that column and then hit compute. And then it gives us everything we need. Isn't that nice? You should be like, oh, that is so cool. I like that. Okay. So where'd we leave off? Summary stats, columns, highlight the column.
Mr. Zarsky, is that basically instead of using like the calculator, is this a
Yep.
convenient? Okay.
Highlight column, compute. Now, what you're going to do now, I'm going to tell you a heads up in not only, well, not so much this section, you can use it for this, but you can use this for the next section 3.2, and we'll be talking about that. Little bit of a heads up. In the 3.2, he's going to go kind of down a rabbit hole as far as the formulas, and I'm going to show you those formulas in a few minutes. But I'm just telling you, don't get scared by the formulas. You're not going to have to worry about the formulas. StatCrunch will take care of it for you. Okay? So keep that smile. Keep smiling. Okay. So yeah, you won't have to use a calculator. And like I say, I realized after actually today while we were talking that I had a scientific calculator in the syllabus. And at the time that I wrote the syllabus, we were going to do on-campus testing. And then that changed not too long ago. And I forgot to update the syllabus. So you actually, if you have a scientific calculator, you are welcome to use it. If you have a graphing calculator, you're welcome to use it to do some basic calculations. That's fine. But as far as to do statistical calculations, StatCrunch is going to do our heavy lifting for us. Okay? That makes sense? So give that a try and stick around after class if you have any questions. All right. The other measure of center that we have is called the median. And perhaps you have heard of the word median before. And a lot of times people look at median and think that a mean and a median are the same. Well, they're not. Okay. And you can see here, it says the median of a variable is the value that lies in the middle, okay, of the data set when arranged in ascending order. It's also known as the 50th percentile. So it is the middle value. And you can see I give you some basic steps. Here you arrange the data in order, in ascending order, and then you have to determine the value that's in the middle. So there are two options here. If you have an odd number of values, then it's just the one in the middle. If you have an even number of values, then you have to average the two middles. Okay, so as far as, say, for example, our data, let's go ahead and bring back that 80, 82, oops, 85, and 89. And if I ask you for the median, because there is an even number of values, what we would do is take the middle two and average them. So 82 plus 85 over 2 would be 83.5. Okay. But let's look at, well, what if you have an odd number of things? Let's have some fun with this. What if we go, for example, we have 80, 82, 85, 89, and 900. then the median, if you got an odd number of values, the median is just the middle one. That's 85. And you're like, wait a minute, you look at that 900, isn't that 900 gonna do anything? Well, no, actually, that's one thing that's cool about the median, and I have that on the next slide, is that the median is resistant. We say that it's resistant because it's unaffected by extreme values. The mean is affected by extreme values. Let me show you. Let's suppose, go back to StatCrunch. Suppose I put that little 900 right there. And then I go ahead and do my summary stats. And look at the mean now, it's 247. So that actually highlights the big difference between the two. A lot of times we use the mean, but if you have data that's got extremely high or low values, you're going to want to use the median. Now, some big examples of the median is when we're talking about like housing prices or even income. So say, for example, I'm going to go to the Orange County Register and pull up an article of, and I'm just going to search the median. I wasn't planning on doing this. So let's see. Let me go ahead and we're going to just search median house. This is a headline that they often publish, just the median price of a house. And look at this. They got an article. It says a housing market about to crash. Okay. And typically what you'll see is when we're talking about housing, and you should know that, yeah, housing, especially in Orange County, it does have some extremely high and some lower values as far as the value of a house. And so you can even look right here. It said median prices. That's why we use the median, because it's unaffected by multi-million-dollar houses. They're multi-million-dollar houses like Newport Beach, Coto de Casa, Huntington Harbor. I live in Yorba Linda. Even in Yorba Linda, they're like multi-million-dollar houses. I don't live in one of those, but there was one I remember that sits up on top of a hill that a few years ago sold for like 30 million. Okay, so we use the median for things like housing prices and annual income just because it's not as affected by these extreme values. So as a statistician, if you were wondering when do we use it, if you've got extreme values, you're going to want to use a median. Okay. And then the third of the main measures of center is the mode. And, oh, you know what? Yeah, I got something here to say before the mode. This goes to the resistance thing. You can see here, okay, if the mean and the median are pretty close, then you're looking at, well, symmetric data. If the data is nice, then the mean and median are about the same. And that's what it says. If it's symmetric, then the mean and the median are roughly the same. However, let's look. For skewed right means you got extremely high values. What happens when we had that high value of 100? The median stayed the same, but the mean got pulled up. So extremely high values will pull the mean up like that 900 did. Or the same is true when you've got low values is going to pull the mean down. So let's go ahead and write that down, something for slide number 8. In slide number 8, we'll say that the mean tends to be pulled toward extreme values. And so because of that, we say that the mean is not resistant. When you watch the videos, the author will be talking about that, resistant. Okay. And then now the last of the measures of center, the mode. The mode is just the most common occurrence. You only have a mode if there are repeated values. So to have a mode, you need to have repeated values. So I'd say need repeated values. Like the data that I have, none of them are repeated, so there's no mode. The mode is just the one that occurs the most. Okay. So in the homework in this section, a lot of the problems are going to be just find the mean, median, and mode for a set of data. And you can use StatCrunch to find the mean and the median. Okay. The mode, you just have to count up which one's the most common. All right. So that's 3.1. Let's go ahead now. 3.2 is where we get to the measures of spread. Now, that's kind of a new thing. Usually in math, you talked about average, middle measure, measure of spread. What's up with that? Okay, we have three main measures of spread: the range, the standard deviation, and the variance. Now, the range is 3.2. The range is just highest minus lowest. Okay, and you can see that I've got it right here. The thing about the range is we don't always use it very often. The one that we use the most, so let's see, I'll make some notes on the side. The range is the highest minus the lowest. But the one we really like to use is called the standard deviation. And you can see here, there is this fun formula. And you're like, oh, what? Am I going to have to do that? No, it's in StatCrunch. And so as far as that formula, you don't need to worry about that. Again, it's in StatCrunch. The main thing you need to worry about is the symbols. Okay. We use the letter S to represent sample standard deviation. And I'll say SD for standard deviation. And then there is a Greek letter sigma. You can see it right there in the formula. That's the symbol for the population standard deviation. Okay. Now, there are some differences in these two symbols, okay, and in the formulas. Like you can see right there, the population standard deviation, that sigma, it says that's equal to square root sum. It's got that sigma, so you add up, you go x minus mu squared over n. And then for the sample standard deviation, the formula is in 2 slides, is right there. It's similar, but different. Again, StatCrunch has these inside. So you don't have to worry about it too much. The most common one we use, generally, we are calculating a sample standard deviation. And again, StatCrunch does this. What you're going to see in the videos as far as the medias, the author is going to do it by hand and show you how it works and what this formula means. Just understand you won't have to calculate it that way. You can use StatCrunch. Okay? Everybody good? All right. So now I'm actually going to show you, take just a couple of minutes to show you how this works, how that formula works. If I take the numbers 80, 82, it's the same thing we did before, 85 and 89. And remember that the mean was 84. So then what we do is we start with the first part of the formula, the x minus the x bar, which means how much difference is there from the x and the mean. So in this case, it would be 80 minus 84, which would be -4. 82 minus 84 is -2. 85 minus 84 equals 1. And 89 minus 84, I don't know if you hear that. That's one of my dogs coming to say hello. Hello. And what he does, he comes up, he takes his snout, and he starts bumping my elbow all over the place to where I can't write. So it basically means I just have to pet him for a moment, and he is okay. All right, gives you a chance to write that down. Okay, so then what we do, that was the x minus x bar part. Then we have to square those. You square them to get rid of the negatives. So -4 squared is 16, -2 squared is 4, 1 squared is 1, and then 5 squared is 25. And then what we do is there's that sigma, so then we add all of those things up. And that is, looks like 46. Yeah. So then S, following that formula, S would be the square root of 46 over n minus 1, which would be 3. Isn't this fun, using the formula? Like I said, you can use StatCrunch, but I just want to show you. And I'm doing this calculation right now, going square root 46 divided by 3. And I'm getting like 3.916. And if we go over to the StatCrunch, not this one, because we had the 900. And look at that. Whoops. Hold on a second. Ha, that 900 is still there. That's why I threw it off a little bit. Hold on. Let me get rid of that 900. There we go. Stat, summary, column, bear 1. 3.916 right there. Standard deviation, sample standard deviation right there. Okay. Easy peasy. Okay, so we have another, I told you there were 3 main measures of center. I'm sorry, measures of spread. And the next one is the variance, but that's really easy because the variance is equal to the standard deviation squared. So the symbols we use, I actually have them right here. I say variance is equal to standard deviation squared. And I did a summary of the symbols. So, and you can see that right in here, when we're talking about a variance, we use the same letters as we do for standard deviation, but put a little square right up there. Okay. All right. Okay. Now you might be thinking, okay, you know what, I can do this. I can do a little bit of stat crunch, not too bad. Now the thing is sometimes people don't know, well, what do we do with the standard deviation? All right, what happens there? So what I'm going to tell you, and this right here is not in the video, but because I got to give you a little bit of background as to what's happening and what they're doing, because usually what happens in the videos, then people start getting super confused. And so what I need to start by telling you is right here, I have written, it says the standard deviation is a unit of measure that's used to measure how far a value is from the mean. And then you look at that and you probably think, okay, Mr. Zarsky, what are you talking about? So let me tell you what I'm talking about. Let's say, for example, I'm talking about IQ scores. Now, by the way, IQ stands for intelligence quotient. So it's a measure of intelligence. And typically IQ scores are set to where the average intelligence is 100. And then the standard deviation is 15. And they're also normally distributed. So I've already given you now the big three characteristics: the shape, measure of center, and the spread. Now, the thing is that we would say that, say, for example, I'm keeping the math easy. If I wanted to talk about the score of 115, 115, we would say, is one standard deviation above the mean. It's one group of 15 above the mean. So can anybody tell me what 2 standard deviations above the mean is? What would be 2 standard deviations above the mean? 2 15s. 2 times 15 above the mean. Jasmine? Yeah, it would, well, 2 standard deviations, that's 30, but above the mean would be 130. Because remember, the mean's in the middle. So 130 is 2 standard deviations above the mean. And then 3 standard deviations above the mean is 145. 3 standard deviations above the mean. Now, we can also be below the mean. And again, I'm keeping the math easy. Let's go 1 standard deviation below. That would be 100 minus 15. That would be 85. Is 1 standard deviation below the mean. Now, let me do these. I'm going to put these in a picture, in a bell picture. I draw a bell. Again, 100 in the middle. And I'm going to mark it off in 115 for 1 standard deviation above, 130, 2 standard deviations above, 145, 3 standard deviations above. And then 85 would be 1 below, 70 would be 2 below, 55 would be 3 below. Okay. Now, you might say, well, okay, Mr. Zarsky, why did you do this? Well, the thing is, the reason why I told you this here in this slide is how a standard deviation is used is because they go into this thing called the empirical rule. And the empirical rule says that if you have bell-shaped data, then we expect 68% of the data to fall within one standard deviation. And usually what happens when people start hearing, if we didn't talk about the IQ things already and I made that picture, you would have been like, okay, wait a minute, what's going on? What's he doing in these videos? Okay. All right. So like with IQ, we would expect about 68% of the people to have a score between 85 and 115, one standard deviation below and above. And then if we're talking two standard deviations above and below, that would be from 70 to 130, and that would be about 95% of the data or of the people have IQ scores between 70 and 130. And then 99.7, almost everybody falls between, I'm going to go ahead and use the red just for another color. So from 3 standard deviations below to 3 standard deviations above, that's 99.7% of your data. So some of the homework problems are going to ask you about the empirical rule, and the 3 key parts involve the 68% within 1 standard deviation, 95 within 2, 99.7 within 3. And we have a nice graphic right there that basically shows the same thing, just not with the IQ scores, but just in general. Okay. Now, one thing that we do is we have kind of a rule of thumb that we would say that values are considered unusual if they are more than 2 standard deviations away from the mean. So we would consider anything more than 2, like where I've highlighted, those would be unusual. So unusually high or low values, somebody that has an IQ above 130 or below 70 is considered unusual. You'll have some questions in the homework about is it usual or unusual? And that's what you got to look at. Is it more than 2 standard deviations from the mean? Okay. Any questions? Questions, thoughts, comments? Let's look at an example real quick. And this example is on, let's see, we are in section 3.2. And I said problem number 34. Unfortunately, I don't have a page number for that, so it'll take me a second. Well, you know what? Let me just go ahead and show you some of the exercises and what you get to do. So let me start with page 147, and then I'll get to that problem 34 in just a moment. So section 3.2, this is, we'll start page 147. And you can see here, it says, now, I know in the directions it says by hand, find the population, variance, standard deviation. Okay, you do that on StatCrunch. Okay, now, in fact, that kind of reminds me of one thing. Let me show you at StatCrunch. Hold on. Remember right here when I showed you standard deviation, it automatically gives you the sample standard deviation. But what if you want to find the population? Okay, a little bit of note for your notes. You go to options. Well, let's edit. If you want a population standard deviation, you want to find, they call it here the unadjusted standard deviation. So the unadjusted standard deviation and variance, that's the population that's using the other formula. So make a little note that you choose the unadjusted is the population. So if you have to calculate population standard deviation, that's where it is. It's the unadjusted. Okay. So you get some data. And again, you can use StatCrunch. Totally good. And then now looking at the next page, like number 34 is where I wanted to go. And let's see, where is that? Okay, this is where they start asking about the empirical rule. So it says, no, there. Okay, there we go. It says the distribution of the length of bolts has a bell shape. See, they tell you the distribution, the mean, and the standard deviation. So about 68%. Notice these percentages go right with that empirical rule that we talked about. 68%, that means you got to go one standard deviation, one of these 0.007 above and below the mean. Okay. So those are the kinds of questions you get to answer. And I'm getting down to the last 3 minutes of class. So what I'm going to do is go ahead and wrap up there. Don't leave yet. Okay. When I start wrapping up, that doesn't mean leave. Okay. What that means is, well, wrap up and I will get you done. I will be done with you at 11:50. All right. So first of all, to refresh your memory a little bit, of course, the next time we meet is in 2 weeks because there is a holiday next Friday. And that date is 2/17. So the next time we meet is on the 24th. So that's where, so the next meeting is on 2/24. So that's why a lot of the work, of course, I extended it to the 24th. All right. And you are going to need to, okay, do everything. Okay, because what we're going to do is by the end of class on the 24th, we're going to finish chapter 4, and there will be an exam the very next week, our first exam. So we move along quickly. Falling behind is not an option here. Okay, so keep up with the assignments. The quiz next time, we are having a quiz. All right, so quiz number 2 will cover the new stuff for today. So the new stuff for today was 2.1 through 2.4, and then 3.1 and 3.2. Okay, so you're going to want to work through all those sections between now and the 24th. And then, of course, you got to do the medias. Okay, get through all of the media assignments. And so if I flip over to my lab, and again, if it seems like a lot to keep track of, the home screen in my lab tells you exactly what you need to do and when, or you can look at the assignments screen. If you go to assignments, they are all listed right there. So just keep going. You can repeat the assignments if you want to get 100%. And what you're going to want to do is do all of these assignments all the way down to the last one of the section 3.3. Oh, wait a minute. And then look at that. There's more due on the 24th. Okay, so everything, yeah, you got to do all the media is actually all the way through 4.2 media. These are listed in order, not in order that they're due, but just in kind of numerical order. So notice that, yeah, there's quite a bit to do over the next 2 weeks. Pace yourself. Don't wait till the last minute, because then bad things happen in the class and we don't pass and it becomes a waste of time. So don't do that. So with that, it is 11:51. Stick around. office hours will start in just a moment. Let me go ahead. You all have a great weekend and a great holiday weekend next week. And I'm going to go ahead and pause the recording and end class. And if you need anything, stick around.